Hi there, and welcome to this lesson. In this lesson, we'll be learning about factors and multiples. Okay, so factors and multiples. And under factors and multiples, we'll be learning about the greatest common factor. Okay, so in the last lesson, we did the least common multiple. This time, we're talking about the greatest common factor. Pretty much quite similar, to be honest, but then just a slight difference between the two, and we'll understand all of that shortly. Now, as the lesson progresses, anything you don't understand, be sure to contact your tutor, who would be more than happy to help. So yeah, let's jump right into the lesson. So factors and multiples, the greatest common factor. Now, what exactly are factors? Okay, so we have the greatest common factor, and just like the least common multiple, we're going to break this down one after the other. Okay, so we start with factor, and then we do common factor, and then we learn what the greatest common factor is. So what exactly are factors? Now, the factors of a given number are numbers that can divide the given number without remainder. Okay, so a number that can divide a number is a factor of that number. Okay, so the numbers that can divide 10 are the factors of 10. The numbers that can divide 10 without any remainder are the factors of 10. So, for example, we have 12, and these are the numbers that can divide 12. 12 can be divided by 2 without remainder, 3, 4, 6, and 12. Okay, and these are the numbers that can divide 12. Similarly, 20 can be divided by 2, 4, 5, 10, and 20. Now, these are the numbers that can divide 20. Quite simply. Now, let's talk about common factors. All right, so common factors. Now, you could be asked to find the common factors of 12 and 20. Now, we already established that the factors of 12 and 20 for 12 we have 2, 3, 4, 6, and 12, and then for 20 we have 2, 4, 5, 10, and 20. And quite simply, the common factors of 12 and 20 are the numbers you find amongst the factors of 12 that you'd also find amongst the factors of 20. And if you look closely, you'd see that we have 2, and we also have 4. Do we have any other numbers? No, that's pretty much it. Okay, so the common factors of 12 and 20 are 2 and 4. Simple. Now, the greatest common factor. Okay, so what is this about? So we already established the common factors of 12 and 20 are 2, 3, 4, 6, 2 and 4. Okay, the common factors, not just the factors. The common factors are 2 and 4, and as such, the greatest common factor is simply the biggest one, the largest one. All right, and in this case, what we have is 4. Remember, when we're talking about the least common multiple, the least was the smallest one, but in this case, for the factor, for GCF, or some people call it HCF, highest common factor, we're looking for the largest number. Okay, so in this case, the answer is 4, quite simply. Now, what if you were asked to find the greatest common factor of 42 and 60? Okay, you pretty much follow the same pattern, and basically you identify the factors of 42. And the factors of 42, numbers that can divide 42 without remainder, are 2, 3, 6, 7, 14, 21, and 42. And then 60, we have 2, 3, 4, 5, 6, 10, 12, 15, 20, 30, and 60. Okay, and generally you just identify the numbers that are common, and what you find is you have that 2, 3, and 6 are numbers that are common between 42 and 60 amongst the factors of 42 and 60, and the greatest one is pretty much 6. So your GCF is 6. But then just like we did in LCM, there's actually a far easier way to solve for the greatest common factor that won't require you to write out all the factors of each number. Okay, and then it's actually very similar. To find the greatest common factor of 42 and 60, what we do is we draw our table. All right, that's where we start, and then we put in 42 and 60, and then we introduce our prime numbers. So draw table, introduce your numbers 42 and 60, and then bring in your prime numbers. So what we're going to do quite simply is we're going, just like we did in LCM, we're going to divide using prime numbers. But then there's one very important distinction. There's one simple difference between GCF and LCM, okay? And the one distinction is the fact that for GCF, whatever number you're using must divide all the numbers, in this case the two numbers. All right, so any number we're bringing in must divide 42 and divide 60. For LCM, we use numbers that can divide any one of the numbers. Okay, as long as you could divide any one of the numbers, then the prime number would be accepted. But in this case, any number we bring in must divide 42 and 60. All right, so what prime number can we start off with 2? Can 2 divide 42 and 60? Yes, 2 can actually divide 42 and 60. And basically when we divide 42 by 2, we have 21. And then we divide 60 by 2, we have 30. Okay, now we have 21 and 30. Now, can we use 2 again? No, we can't use 2 again. Reason being, the prime number must divide both numbers. Now 2 can divide 30, but 2 can't divide 21, and for that reason in GCF we cannot use 2. If we were solving for LCM, as long as 2 could divide 30, we would accept 2. But for GCF, remember this, GCF, the number must divide both numbers, okay, or all numbers. If you have a set of 3 numbers, it must divide all 3 numbers. So in this case, we can't use 2. Now, let's try 3. Can 3 divide 21 and 30? Yes, 3 can divide 21. It can also divide 30. Oh, so we bring in 3 and we say 21 divided by 3 is 7. And 21 divided by 10. And 30 divided by 3 is 10. Now, if you look at 7 and 10, basically at this point, there is no number that can divide 7 and 10. All right, and this is where we stop. Okay, for GCF, whatever number you're using to divide must be able to divide the two numbers. For LCM, you divide all the numbers till you get to the point 111. All right, but for GCF, you only divide to the point where you can't divide again, because whatever number you're using to divide must divide the two numbers, or must divide all the numbers you're trying to divide. And if you look at 7 and 10, there's no number you would use to divide 7 and 10. And from this point, this is pretty much the end of your work. All right, and you just go ahead and say 2 times 3 equals 6. So the numbers you use to divide 2 and 3, and you multiply them, you say 2 times 3, and it equals 6. And that is how you find GCF. So very similar to solving for LCM, the only difference being this time when you're dividing, the number you're using to divide must divide all the numbers, or must divide the two numbers. So let's go ahead and do some examples. So example 1. And example 1 says, what is the largest number that can divide 24, 36, and 72 without remainder? Now, quite simply, we're looking for the greatest common factor, i.e. a common factor between 24, 36, and 72, and pretty much looking for the largest one, the greatest one. And now, how do we go about doing this? We just go ahead, draw our table, put in our numbers, and bring in our prime numbers. And then we start dividing. Now remember, we need to find a number that would divide 24, 36, and 72 at the same time. Okay, so if you look at what we have there, basically these are all even numbers, so we can actually divide all of them with 2. Okay, so 24, 36, and 72 we can divide with 2, and dividing that with 2, 24 divided by 2 would give you 12. 36 divided by 2 will give you 18, and 72 divided by 2 will give you 36. Okay, now we can go ahead and divide with 2 again, and 12 divided by 2 will give you 6, 18 divided by 2 will give you 9, and 36 divided by 2 will give you 18. Now at this point we can no longer divide by 2 because 9 can be divided by 2, and following the way we solved for the greatest common factor, all numbers, you must be able to divide all numbers at the same time. So since we can't divide by 2, can we divide with 3? Can we bring in 3? Yes, we can actually bring in 3, and we have 3 because we can divide 6 by 3 to give you 2. You can divide 9 by 3 to give you 3, and you can divide 18 by 3 to give you 6. Now we have 2, 3, and 6, and I'll tell you at this point we can't divide any longer because there's no number that would divide 2, 3, and 6 at the same time. Considering we actually have two prime numbers there, so we can't divide 2, 3, and 6 with any number. So there's no number that would divide 2, 3, and 6 at the same time. And so at this point what we do is we just go ahead and say 2 times 2 times 3, and it gives us our answer 12. So the GCF of 24, 36, and 72 is 12. Now example 2. In example 2 says find the GCF of 45, 105, and 165. And quite simply, we have our table, our prime numbers, and looking at our numbers that we definitely can't divide by 2, but we can divide by 3. So we start with 3. 45 divided by 3 gives you 15. 105 divided by 3 gives you 35. 165 divided by 3 gives you 55. And then 5. Now 15, basically looking at our numbers there, we can divide with 5. We can't divide with 3 any longer, so we move on to 5. And then 15 divided by 5 gives you 3. 35 divided by 5 gives you 7. And 55 divided by 5 gives you 11. Now at this point we obviously can't divide any further, so we just go ahead and say 3 times 5, and it gives you 15. And that's it. Very simple principle. Okay, so you can now go ahead and attempt questions on the worksheet, and yeah, bye for now.